Hi, everyone. Thanks for joining us for the webinar today. While we wait a minute for everyone to join, please take a moment to respond to this poll so we have an understanding of how familiar everyone is with chaos engineering. And so today we are presenting Ensure Redis Reliability with Chaos Engineering. The webinar is being recorded, and you'll get a note from us once the recording is available. And that's usually within 24 hours. So we'll have 10 minutes for Q&A with our presenters, and you can ask your questions at any point in the Q&A chat. You'll also be able to upvote other people's questions, and we'll go through all the questions at the end. So we'll just wait a minute for more folks to join, and we'll get started here in a minute. So if you get a chance to answer the poll, that'll help us with the presentation. Right now, it looks like most people have at least heard of chaos engineering. So that's a good start. All right, we'll get those last poll responses in, and then we will get started. Okay, without further ado, I will pass it over to Tammy and David to get started.
Hi, everyone. My name's Tammy Budo, and I'm a Principal SRE at Gremlin. So excited to be here today to speak with you all about ensuring Redis reliability with chaos engineering. So now I'll pass it over to David to introduce himself.
Hello, everyone. This is David Herndon with Redis Labs. Appreciate you joining us today, and thanks to the Gremlin team for hosting all of this. We're excited to be here.
Awesome. Thanks, David. So let's get started. First off, let's touch base on Redis reliability. So there are a few different things that you can do to ensure that how you've set up Redis is in actually a reliable way. The number one thing to start off looking at is in-memory replication. Number two, node replication. And number three, cross-data center replication. You can see here I've used the word replication 3 times. If you're not sure about replication, what you're doing here is you're basically making a copy. You're replicating data. So that's the whole idea there. And why would you want to do that? It's always better to have more than one copy of your data at all times. That's a very important thing. I have a long history of working with databases and data stores. I previously worked at Dropbox, and I was the SRE manager for the databases team. So obviously replication is very important. And there are 3 things that you can do out of the box. So often I like to think about it from starting small in memory replication. Then you want to think about how can I actually replicate data across nodes? And then how can I actually replicate data across data centers? So making an entire copy of all of one data center and putting it over into another data center. This helps, for example, if you're like on the East Coast and the West Coast of the USA. So why would you want to focus on reliability? Well, complexity keeps increasing. So back in the day, not even that long ago, some companies actually still do have monoliths. So that was more of the architecture that we had. It was pretty easy to understand, what your architecture was like, what it looked like, because really it was like a giant ball of code in this giant monolith. So you knew where to go. You looked at the one giant repo and you could see everything. But now we have this more complex architecture, the architecture of microservices, where you can see there's actually a lot of dependencies, both upstream and downstream. And this means there's a lot of moving parts and a lot of things that need to work reliably for the customer to actually have a great experience. On the left is the microservices architecture diagram for Amazon.com. This is obviously impossible for one person to remember or one person to be able to actually grapple all of this complexity and then be able to communicate it with another person. It's just so much. You would be in meetings for years probably trying to explain this architecture. On the right, we've got Netflix. So this is all of Netflix as well. Imagine joining Netflix and needing to onboard and understand how this architecture works. It takes a long time if you just try and read through diagrams or speak with people. It's just really, really hard to understand what needs to be reliable, what are the critical paths, what are the critical components, what needs to work every day for customers to get that great experience, to be able to just simply open up, turn on their PlayStation, click on Netflix, and start watching their favorite movie or TV show. That actually requires a lot of things to work reliably. So we asked this in the poll, have you heard of chaos engineering? For folks who haven't yet heard of chaos engineering or aren't sure of a definition, chaos engineering is thoughtful, planned experiments designed to reveal weaknesses in our systems. So how do you actually get started practicing chaos engineering? We like to have a scientific approach. So like I showed you before with these giant architecture diagrams, one of the first things you want to do is you want to focus on a specific area. I like to say, try and identify what your top 5 critical systems are. When you join a new team or when you join a new company, or even just at the company that you're currently at, if you ask people across your company, hey, what do you think our top 5 most critical systems are? Some people just actually won't know, or other people might guess, or you might get different answers. So the first thing we want to do is observe the system, understand how the system works. Then we want to try and set some baseline metrics. So this is important because if we set our baseline metrics, then when we do our improvements work, we'll actually be able to measure it and say, we did this work and we achieved this outcome, and it actually made our metrics improve in this way. That's a really good thing to do as an engineer. Always sweat the details and be metrics focused. So some example metrics could be SLOs and SLIs per service. So service level objectives and service level indicators. Step 3 is to form a hypothesis with abort conditions. Step 4 is to define the blast radius. Start small and gradually expand. Step 5 is to run the experiment. Step 6 is to analyze the results. Step 7, expand scope and retest. And then step 8, share your results. So actually call back to those baseline metrics that you had. So say, for example, if your service took in the past maybe an hour to detect an incident, but you were able to do chaos engineering, you improved your monitoring, you improved your alerting, and now you're able to detect incidents for that service within 5 minutes. So your mean time to detection went down to 5 minutes. Like, that's a really awesome result to be able to share. So how do you practice chaos engineering with Redis? Well, now I'm going to hand it over to David to talk about this.
Thank you, Tammy. Again, this is David Herndon. Appreciate everybody joining. So I want to kind of put this slide up first because I think there's some confusion in the marketplace. A little bit when people talk about Redis and Redis Labs. So Redis, of course, is the open source in-memory database, well known in the market for high performance. We sit in front of a lot of different databases and application systems to speed up people's response times. These days, everybody wants everything now. They want it instant. And if we can give them millisecond response times on their database requests, then they're all happy. So the open source core is a NoSQL, or what I call a non-relational database. We use commands and key values. And Redis Labs is the primary sponsor and the open source home, so to speak, or the commercial provider of the Redis open source. So our engineers help build the open source, and as well they work on the enterprise features and technology. So we are the home of Redis and the commercial provider and supporter of Redis Enterprise, which we're going to talk about today. So if we could jump to the next slide, please. Thank you. Let's talk about a few specifics here. We probably could go on for 10 or 15 high-level bullet points, but today we're going to focus on how do you set up a Redis Enterprise instance, how do you make it obviously scale and continue to have that potentially sub-millisecond response time, but also how do you enable high availability, because it's not really worth having a database cluster that's going to respond fast if it's not highly available. So we're going to talk about that a lot. And of course, with Redis Enterprise, we provide a centralized set of REST APIs and also a web application or a GUI to help you manage large-scale implementations of Redis on multiple servers. So we'll be talking about that a little bit as well. We also provide out of the box graphs and charts and things and monitor things right on the dashboard of that GUI I mentioned. We also have real-time alerting, so if you have a situation on your server. And we also support Prometheus endpoint for scraping data and pulling that into tools such as like Grafana and other tools that can read that to provide sort of a more sophisticated dashboard experience. And all of those metrics are also available in our REST APIs. And last but not least, and I don't know if we'll get to this today, but active-active. So Redis supports out of the box the ability to create a second copy, if you will, or have another cluster that works on the same database that, say, if you had an East Coast and a West Coast situation, and having those databases kept in sync. And it can be used for active-passive, and today we'll talk about that a little bit, but it's also enabled with our CRDT technology we'll talk about in the active-active fashion, so that you can update, you can have users working against their local copy of the database on the West Coast, and then also have users in the East Coast doing it. And Redis will keep those two copies, so to speak, in sync with each other, and also help you resolve any conflicts. Actually, it does a lot of it automatically for you through some pretty sophisticated algorithms that we support out of the box. So we'll talk about that a little bit more. Next slide, please. Yes, this is a super high-level overview of Redis Enterprise. So on the left side of the picture here, you notice the little red boxes at the bottom. We do package in the open source, the latest version, when we release a new version of Redis Enterprise. What we call the shards, or the OS process that's actually doing the work of getting the data and that back to the clients when they ask for it. So the red boxes are multiple potentially Redis processes running on a server and coordinated by the portions that we provide in Redis Enterprise, which are in the blue layer that you see there. So we have a proxy in Redis Enterprise that really offloads the task of connections from end clients. And it does a whole lot more we can't go into today, but it allows you to scale more. It allows the cluster to be smart and be aware if there are problems with shards or nodes entirely. And it works in conjunction with our cluster manager to make sure that the databases that are represented in those shards are highly available and as well scalable. So all of this comes together with our web UI and our secure REST APIs that you can actually write against as well to do administrative things, and you can even build your own custom dashboard based on those REST APIs. A typical implementation of Redis would be a minimum three node, 3-server cluster, always an odd number, so we have a quorum, and fully compatible with the open source commands and data structures. The next slide for me, please, Allie. Thank you. So what I'm going to do today is when we get to the demo, you'll see a lot of this in action, but let's talk through it first. So this is kind of a 3-node cluster setup here. We've got a client app that's actually connecting to node 1. At this point, it could possibly be any of the nodes, or it potentially could be a mix of nodes. In this case, we're talking through the proxy on node 1, and we have a single database that has a master shard. And then we've enabled high availability for this database, and it has a replica shard on node 2. So those are 2 copies of the open source Redis instance that are coordinating with each other, and any updates that happen to the master shard are going to be automatically and quickly replicated over to node 2 in this scenario. So the next slide will show us, inevitably, the gremlins show up. So what happens when I lose my master shard? If you're using open source, pretty much you're connected directly to the shard. In our situation, we have a lot of sophistication built into that proxy, as well as the cluster manager that allows you to recover from a situation like this. And frankly, in most cases, the clients probably will not even know that something happened. There's certainly an amount of error checking that you need to do in your code to make it as rock solid as it can possibly be on any kind of disconnects you might get. It depends on the scenarios. But in most cases, it happens super quick, and it's pretty much transparent to the end client. So this shard is dead. Something happened to the process, or what I'm going to actually show you in the demo is the entire node is going to crash. The next slide shows you what Redis does in the response to this. So it's already got the replica shard on node 2. So it's all really good to go if it detects that node 1 is not responsive or the shard is not responsive, and it automatically switches over and promotes that replica shard on node 2 to be the new master shard. And so the proxy is aware of this happening, assuming the whole node didn't go down. The proxy is aware and it can redirect any pending traffic to node 2. And again, the clients really hardly notice anything's happened in most situations, and it just keeps on going. And we'll see some of that in the demo. So the cluster manager and the proxy coordinate, they come to the rescue, and we're all good to go, and things are all happy and rosy again. But the next slide will show us too, an extra step that we take. Well, what happens on node 2 is something just by coincidence happens to that shard if the OS process crashes. As soon as the master shard is promoted, and you can actually dial this in, you can say give it 30 seconds or give it 10 minutes. You can turn it off even and just go by the alerts and manually go resolve the issue of having only one shard. Or you can have Redis go ahead and spin up a new replica shard on, of course, another node for high availability. You can have that happen automatically. So in this situation on this graphic here, you'll see that Redis has gone ahead and created that new replica shard. Now you can leave that as is. Obviously, you're probably going to get an alert that something happened on node 1. You may be monitoring things, and you may notice that Redis kind of took care of things for you. You may just leave it as it is, or you may decide, and I'll show you this later in the demo, to move everything back to node 1 once you've checked it out and you're kind of happy that things are okay. It was just a random occurrence or something happened to that process. You don't have to do that. In this situation, it might be more optimal because it's typically better to scale up on a box and have the master shards on the same machine as the proxy. That way there's no extra little hop across node 1 to node 2 for the proxy to get the data going forward. But that's something that you can go back after the incident occurred and kind of adjust that. Okay. So I think at this point, we're going to jump on into the demo. Let me set this up just a little bit. First thing we'll do is we're going to show you Gremlin, and we're going to show you Redis Enterprise, and I'll walk through the details of what I've got on the screen for you. We're going to do a warm-up attack. So we're just going to basically attack node 1 and see what happens, just to get you used to the Gremlin tool a little bit if you haven't seen it, which is it's just awesome. It does so much for you. That'll be a warm-up, and then what we're going to do is actually instead of just a crash shard, I'm actually going to walk through a complete node 1 crash. So the motherboard fried, somebody pulled the power plug, who knows what happened, but the entire node went down, and what are we going to do in response to that? And then lastly, I'm not going to give any spoilers out. Assume we survive, the second attack there. We're going to do what I'm calling the total devastation attack. So what we're going to do is we're going to attempt to go ahead and just crush the entire cluster and just see what happens when that happens to Redis. So we'll should be exciting. So, and I think with that said, let's just jump right on to the demo. I'll switch over.
Okay, so let's take a look at our demo setup here. Let me walk you through a little bit about how I've configured all this. I know it's a lot of windows to look at, but hopefully it'll make sense to you when we step through it. Over here on the far left, I've got the browser window and several things loaded up here. This is where we're going to launch things from. All of this that you're going to see is live and working and built out in Google Cloud. I have 3 Redis nodes, node 1, 2, and 3, and there's some other stuff in here. But those are the 3 primary nodes of Redis Enterprise that are running. It's also a test machine. This is actually where the mem tier client is. It's a client that puts load against Redis server. It does puts and gets or sets and gets, and drives activity on the cluster to make it work hard for us and make it look good in the demo. So on the next tab over, we have the Redis Enterprise Management Console. And you'll notice if I click on cluster here, you'll see we're not really doing a whole lot against the server now. It's not working too hard. You can see the CPUs aren't working very hard on node 1, which is where most everything lives right now. But we are doing it very low latency. In fact, I'm not sure why that's reporting 0, but it's really not working hard at all. And I may increase that number here in just a minute. We'll see if we want to bump that up a little bit more. It's not really a load test we're doing today. We have plenty of case studies and benchmarks for load tests. Today is more about the resilience of Redis Enterprise when Gremlin takes over and tries to trash the server or the cluster. So we'll come back to this. We'll be using this screen as well. Of course, we have the Gremlin dashboard, sorry. And we'll come back through this, and I'll show you some of the features as we launch some of the attacks. Lastly, we also have Redis Insight, which is our GUI front-end web-based tool for querying various databases, both open source as well as Redis Enterprise databases. So you can just simply get commands like I've done here already. There's a key out there in the database called foo, and when I get it, I get back bar, right? Classic there. So on the right side of the screen, we have some of the nodes that make up the cluster. So this is Redis node 1 in that Google cluster, and I'm running htop here. So it's showing us the processes sorted by CPU percent. It's also at the top giving us a graphical view of the 16 cores that are available in this box and how hard they're working. So we'll be using this to monitor some things. This is Redis node 1 as well, and this is a terminal shell that just is running the RL admin command. That is a Redis Labs tool for letting you look at, most importantly, like the status of your database. When I run that, you'll be able to see the details of the shards that are running. Now, shards are, there's two types, master shards and replica shards. And the master shards are the actual writable shards. You can have one shard in a database. You might want to have a slave or a replica shard as well, and that would be your backup shard. So in this case, what we're seeing here, this database actually has 4 shards because we want it to be bigger than would fit in one shard. Let's leave it at that for now. It's about how do you size things in Redis. You can have many shards across many servers. But in this case, we've got 4, and all the masters are running on node 1. So they're all up here, and you'll notice the processes up here. There's a number associated with 308, 312. You can actually correlate those to the shard numbers in this list. So we see that 312 is actually one of the master shards running on node 1. And that particular one, it's hard to tell from here exactly which one is the replica shard, but it looks like all the replica shards are running on node 2. Okay? So these guys are busy answering calls from clients through our proxy on Redis Enterprise, and they are serving up data as fast as they can. So what we're going to do is we're going to kick off a test here in just a second that makes them work even harder. Now down at the bottom again, this is our mem-tier benchmark, and mem-tier benchmark is just a tool for applying sets and gaps, or it can be any Redis commands against a cluster or a Redis database, and you can scale it up to multiple threads. And this is a separate server called Redis Test, just so we can have this guy running on a separate machine and not interfering with the actual database processes on the server. Okay, and I've got one more window here on node 3 of the Redis cluster, just in case something happens to node 1. I have a feeling it will. And that way I can still see the status of the shards and have a place to jump in and quickly go check what's happened with node 1 or node 2 if something happens to them. Okay, so that's kind of the lay of the land. Let's jump back over here. We'll confirm that we are processing some ops per second, 134,000 to be exact, and which is actually a lot, but typically if I put this up to I don't know, 30, 40 threads or clients. This is an 8-way core, so I didn't want to overload it too much either. But you can get this number up to 500,000-600,000 easy, probably even 1 million if you tune the server properly. But again, we're not really load testing today. We're doing resilience testing. So speaking of which, let's go ahead and kick off our first test. So this is the Gremlin tool, and the Gremlin tool allows you to create attacks against any number of servers or other pieces of infrastructure in your network. I have the Gremlin agent running on nodes 1, 2, and 3 of my cluster. And this particular attack that we're going to do now is a one-off attack. You can create scenarios. You can have multiple attacks, coordinate them over different phases of a much more complex attack. But we're just going to stick with a simple attack today. So I'm going to go in and click new attack. Okay. And you'll see that Gremlin tells me I have 3 hosts available. I can click on this, or I can just go ahead and pick the host down here in the list. And what we're going to do is we're going to do a CPU attack against node 1 just to warm things up a little bit. So I'm going to pick not one of these guys. I'm going to pick IP address .89. That is node 1. I just happen to know that. And you'll see, so it's really a third of my infrastructure. I've got a nice little graph there so you can kind of load balance some things if you want to for a much bigger test. But we're just going to pick that one right now. There's some tags and parameters. And again, the agent's running on it, so it knows all about the server. And then I'm going to come down and I'm actually going to choose my Gremlin. So what is it that I want to do? Network attacks, especially the black hole. That one's a pretty cool one. It really does wreak havoc. The state attack, process killer, shutdown. We'll come back to that. Let's just do a simple resource attack and watch Gremlin really go after the CPUs on this server. And I'm not going to do it for very long because we don't have forever for these demos. I'll do it for like 20 seconds, and that'll give us a good idea of what's going to happen. And in this case, we're not going after anything other than all the cores. We don't want to put any additional parameters in there. So pay attention up here, pay attention down here. Redis client keeps on going, and I'll flip over to the administration console and see how the CPU attack definitely affects. Let's unleash the Gremlin. I'm going to jump back over here. It looks like it's pending. It should kick off. There it goes. All right, so you'll notice my ops per second. Yep, really can't avoid that. Somebody's hogging the CPUs. If you look up here, we're getting close to 96%, so we're very much saturating this machine. And Redis is still going, but it's not quite delivering the performance that we had before. But you see that comes back pretty quickly. We'll give it a second just to calm down. And it looks like we're back where we started. So that was just a little warm-up attack so you get the idea of what Gremlin can do at the base level and see a simple attack and how I create that. So let's take it up a notch. Let's go in and do a all-out assault on, we're going to do it on node 1 because that's where everything's being written. Remember I said these are the Redis open source shards that Redis Enterprise has managing this database called Gremlin. We're going to drill into this database now in the console, and you'll see specifics about that database, not just the cluster, because Redis Enterprise, you can host multiple databases per cluster. It is multi-tenant. So we're looking at Gremlin. We see there's about 4 shards. All the master shards are very busy taking reads and writes from clients. And then if we look down on the other machine on node 2, we would see the same similar processes. Those would be the replica shards that are also working. They're probably not working nearly as hard as these guys, but they are taking updates real time. So the way Redis works, as I mentioned earlier in the slides, the failover will happen. If we shut down node 1 or attack something or whatever, Redis Enterprise is going to automatically go, it's time to make this guy the primary over on node 2 because this guy is no longer responding. So that's what we're going to see when we do this. Depends on how you attack the node. In this case, the proxy, it may be slightly disruptive to the clients. The clients will always want to have to trap error messages in your programming to make sure that if you lose a connection, retry the connection, reconnect, and if you don't try in 2 or 3 times, you can't get back in, just keep trying. Redis is going to flip over very quickly to the promote the slave shard to the master and get you back going very quickly. In some cases, you don't even notice it. If I went up here and did a manual failover with the Redis admin toolset, which I'll show you how to do in just a little bit, the clients never even are affected at all. Okay, so let's go back to, we're going to shut down node 1 and have it restart. So let's go back to Gremlin. We're going to go back to attacks. We're going to create a new attack. In this case, we're going to target an exact host again. We're going to target node 1, and we're going to choose our Gremlin we're going to do a shutdown gremlin, reboots or shutdowns on the targeted host. And I'm going to go ahead and have it do it right away. But I'm also going to have it reboot the server. So it'll do a shutdown -R basically. And it'll take just a minute to do this. So I'm going to go ahead and kick this off. We're going to be looking for this guy to start freezing up. This guy will stop working. Then I'm going to do some queries down here to show you how Redis fails over. We'll see this shard on node 2 become the new master, and likewise for all of these. And then we'll see when they come back up, Redis Enterprise will create replica shards back on node 1 and make those the replica shards for the recovery process. So, and you can go and move those back manually if you want them on node 1. In this case, it really doesn't necessarily matter. Redis is just going to keep on running like nothing ever happened. And I'm just going to go ahead and unleash this gremlin. Okay, let's see. Let's just make sure it gets pending or it gets going there. It says it's running. So we're going to watch for that upper right window and see if we start to see the shutdown happening. It takes just a little bit of time, as you probably know, when you shut down a server. It unless you pull the power plug, it doesn't happen right away. So let's go look at Redis. So it's still going through some stuff here. It's good. We'll keep an eye on our client threads down here. And hopefully that shutdown is going to trigger any moment now. Let's see if we're still alive here with our status command and the RL admin command. Yep, everything's okay. So there's no hint of the shutdown yet, but it is coming. And looks like we are still in the running state. So the agents are trying to get it done. Let's do a status there. Still see the slaves on node 2. Nothing's really happened. Oop, I think we've got a freeze up here. I think it's happened. Yep, this guy's locked up. This guy's locked up. Down here, we're probably going to see in the status output. Yep, error down. So it's saying that node 1 master is down. The clients are handling an error response. So they're looking, there's a transaction that was being initiated. And if we come back up here, we'll see that the server is reporting, oh, we're getting pop-ups here. I'll just go ahead and have this reconnect if it will. It might not be back up yet. All right, you already see though, when I did that last status, it's already got node 1 as the slave shard and node 2 is the master for the database. So you see it failed over to the replicas. And then once the node became available, it said, I'm going to put those new nodes, or the new replica shards back on node 1 now that it's available again. And eventually we'll get to a state, there we go, where we see that everything on the right side says it's okay. And let's go back into our RL admin console actually on node 1 and take a look at what it's showing us. There we go. So node 1 is now a replica shard. And all of the master shards are now running on node 2. And our client threads are still pumping through ops per second. Our numbers are up over here. Actually, you know what? I need to refresh this. Thank you for reminding me. We'll refresh the web administration console. And I think it says user halted. I'm not sure what that means in Gremlin. I think it means it finished, it shut down, because it absolutely did do that. So let's come back over here. I'll jump into Redis Insight and probably should refresh that to see if foo is still out there. So we'll do a get foo. There's bar. Okay, so I think we're back up and running. Clients are connecting and having some success getting some throughput there. Got to check on my enterprise server here. And I think the server is not exactly, this is the web server host. Takes him a little bit of extra time to get up and going when the priority of the cluster, of course, is to get the shards back up and running. And in this case, we might not completely have. In fact, I'll just close that tab. It could be a front end issue. And we'll reload that. Give him a second to come back up. So what I'm going to do while we're waiting on that, I'm going to come back over. And remember, I told you that you don't have to do this. We're running fine right now. They just flip-flopped. The master shards holding the data went on to node 2, and the replica shards were rebuilt on node 1. And the server is still responding and keeps moving forward. What we're going to do now is show you how you can move those shards back. So I'm going to go ahead and issue a command line here. I'm just going to say migrate node to all, I can type, master shards target node 1. So what that's saying is I want to take all of these guys that are on node 2 that are master shards, which is this one database. Now, if you had 5 databases on the server, it would do them all. So be aware of that. This is all in the documentation for RL admin, but I'm going to go ahead and kick that process off. You see we're still processing. So I'm going to move data around while the clients are actually busy doing work. And we'll see that the shards finish successfully. So now if we do a status, we'll see that our master shards are back on node 1. So we're back exactly the way we were before we did the server shutdown. It's about that. Okay, so good. Well, how about something, and I probably should come up here and see if I can recover this guy. Yeah, reconnect him. He's having a tough time there. We'll get HTOP running again there so we can see a little bit about what's going on. Yeah, there's our shards back. Now they're the master shards again, and they're all running, and everybody's happy. So let's go see. Let's just make sure we can actually write something into the database, because that's all. I just did a get foo bar, and you actually in Redis Insight, our GUI front end tool, you can come here to the browser. You'll see all the test data that's being thrown in there. It's Gremlin 782. It'll pull the key up for you. It's just garbage, just 300 bytes of stuff that this guy down here is putting in there for you. Or you can use the call level interface, the command line interface built right into the browser. It's kind of nice. Like I did before, I said get foo, and I can also set something. So that's something fairly unique here. Let's do test 1, or test, what do we want to call this? Test complete failure. You know, we'll use a :1 on there because that's kind of nomenclature with Redis to designate a uniqueness in a key maybe. And we'll say this data survived. Okay. And I'll put some gibberish out here just to pad it a little bit. You know, I'm not cheating. And all right. So I put that key out there. That's in the local cluster that we've been working with. I'll do get test complete failure 1. And you see there's my, my gibberish that we put out there. Okay, so here we are. We're going to go back into Gremlin now. And we're going to do the ultimate attack. In this case, we're going to do a complete shutdown of the entire cluster and just watch it collapse. Okay, so let's watch. I'm going to go in and do attacks, new attack, target all hosts, choose a gremlin, and we'll do the same thing again. We'll do a shutdown attack. Again, Gremlin's awesome. You got so many ways to attack the server. Flood the memory, black hole attack, which is great, but it takes a little while to form the black hole, the event horizon, I guess. And for the interest of time, we're just going to do a shutdown again. It accomplishes exactly the same thing. So we're not going to delay anything again on that. And this time, though, I'm going to say, do we want the servers to reboot or not? You know what? Let's say no. Let's say they died. The whole data center sank into the ground. And we're at that point wishing we had a backup plan, right? A failure plan. So this is how we test. Hopefully we've got a backup plan. And I'm just going to go ahead and unleash this. We'll start to see some bad things happen again. Give it a second. And let's see if node 3 is starting to be affected. We'll see some error messages down here now from the clients. So how would we fail over here? What would we do about this? Well, there's a lot of ways to handle this. Of course, you can have monitoring tools. Redis actually exports its metrics from its engine, in the Redis Enterprise engine, through Prometheus. And there's an endpoint for scraping Prometheus. So you can have data flowing out, all those graphs and things and that I was showing you earlier, they can actually go out and be seen in Prometheus. You can use Grafana. You can set custom alerts in Redis, of course. Lots of ways to make this happen. But what you want to do ultimately is trigger something to happen. And what would that be? Well, I'm going to pause a second too and let this finish up because it still hasn't shut down all the servers yet. Anybody remember the movie Contact? One of my favorite movies, and John Hurt as S.R. Haddon. He made a comment in that movie at the end, and I just love this quote. The first rule in government spending: why build one when you can have two at twice the price? He was talking about the spaceship that they had to build to try to go where they were going to go. And the first one blew up. So he came back and said, well, you know what? I think I may have another one. If you've seen the movie, you'll appreciate that. So what does this mean to Redis? Well, it looks like we're in need of it right now because Redis is starting to have issues. And yeah, we're getting no ops here. So let's jump over and take a look at the SR Haddon backup plan. Give me a second here. I've got a window over here I want to bring into play with our secret backup plan. So if our load balancers or some other automated process detected that the database server cluster is down and clients still need to have somewhere to do their work, wouldn't it be great if you had a second copy, just like these guys? So in this case, we did. And I kind of tricked you a little bit. Let me log into this because it has logged out. Go ahead and refresh that. So this is a second Redis cluster that was configured as active with Gremlin, a database called Gremlin. And the other cluster, and it's telling you, I'm having a tough time trying to sync to the other cluster, something's going on. But if you want to connect to this database, you still should be able to do that. So let me click into Redis Insight, go into my secret database, which is on, to show you, instead of the other one was dherndon.demo, this one is dherndon2.demo.redislabs.com. So second cluster altogether of 3 servers. That's these guys over here, node 1-2, 2-2, 3-2. So we should be able to just cancel out of that, click in here, go into the browser, see some of the keys that Gremlin had been sending over. And those are, again, active. Somebody could have also been using this database and the replication of the data would have been happening the other direction. And in fact, that's what's going to happen now. If we change anything, it's going to queue it up until the first cluster comes back alive. And then it's going to send those changes back over to the first cluster. So let's see. Anybody remember what I used? Get test complete failure. Okay. Value 1, I think it was. This data survived. And there's my gibberish in there. So you know I'm not pulling a funny one over on you. Okay, so that is how we would use Redis in an active scenario. That was kind of an active-passive, but again, anybody could have been over here in this database. This client could have been pointed there, or we could have had one pointed at both of them, a set of clients. And Redis is going to replicate the data from each cluster, geo-replicate, across even low latency links with compression, and keep data synchronized across all of those connections and all of the geographic boundaries. You can have a number of clusters that all work that same way. And we use a protocol an algorithm called CRDT. If you noticed in my database, it had that in the name, which is, or CRDB, which is a conflict-free replicated database. That is a algorithm term for how we resolve conflicts when things need to be merged. So that is it, folks. I think we're going to probably go back to the slides.
Awesome. Thank you so much, David. Okay, so now we just wanted to wrap up with some links that we wanted to share with you. So yeah, the first one is that you can create your own Gremlin free account if you go to gremlin.com/free. You can also join 5,000 plus engineers in the Chaos Engineering Slack if you head over to gremlin.com/Slack. And then I'll hand over to David to explain where you can find out more about Redis Labs.
Yeah, thank you. I know we have some questions coming in too, I believe. So we'll check on that real quick. Yeah, looks like we do.
All right. So the first question is from Masa P, which is, what do you mean by automated scalability of Redis? It means that it's a dynamic structure, or it's referring to another concept?
Automated scaling, essentially, I think I can address that, is the fact that you can add additional nodes to your cluster and or add more shards to your cluster if you're not using all the resources on the machine. So Redis can quickly scale up additional shards, which means you're going to use more processor or more memory potentially on the server simply with just really a few mouse clicks. And that's done through what we call sharding or additional sharding. If you had started maybe and you had 4 processes serving up data and you went to 8, then you're going to take advantage of more resources on the machine and typically see more ops per second throughput. So of course, you can always scale out as well. So additional nodes being added to the cluster would wind up with more capacity. We actually did a benchmark about almost a year ago now, 200 million operations per second with less than a millisecond. It was barely, but it was 0.99 millisecond average latency time to serve up the data. And that was on 40 Amazon nodes in a cluster. So I think most people probably don't need 200 million ops per second, but we do have that capacity if you need it and if you've got the budget for some more servers. So I hope I answered your question.
Cool. So we have another question, and this is from Pankaj, which is, why is the graph that we were seeing dipping once in a while to almost 0 transactions? Is this impacting Redis performance?
Yeah.
Flash response back to clients?
No, what you saw, the periodic dip, was the Memtier benchmark spins up a test and it runs like a batch of tests, and then it'll pause and decommission the threads on the client and then spin up another batch. So that's pretty normal behavior with Memtier.
Cool. So if people want to submit more questions, we can continue the Q&A. In the meantime, one question that we often get about chaos engineering is what's a good place to start, and what experiments would you recommend for someone that's new to chaos engineering?
Well, Tammy, I think I'm going to let you handle that one.
Hi, everyone. So the question was, what are some experiments to get ready to do chaos engineering if you're new?
Yep.
Alrighty. So I think like a good place to start is actually to identify what the main problems are that you'd like to solve. And so think about it like this, like, you know, does your company currently have a lot of incidents, a lot of support tickets, a lot of customer problems? Then you would want to focus on using chaos engineering to reduce incidents. And once you know that, then you can really narrow your focus and look at that incident data to be able to bucket and prioritize where you're going to focus your chaos engineering time, and then work to make the specific offending systems or services more reliable via your chaos engineering practice. So that's the main one example of how you could start. Or for example, if you're doing something like a migration to the cloud, then you have a big project coming up, then that's another reason that you could practice chaos engineering. But I think it's always really good to actually match your chaos engineering practice to your business and technology goals. So where is your company heading and what do they want to achieve? That's how you can get some great value.
Great. Thanks, Tammy. So we have a couple more questions. So this one's from Masa, which is, how are the number of required replica or redundancies defined? And that's for David.
Yeah, well, that's in Redis Enterprise, and you guys probably know Redis, the core open source engine, actually drives a lot of other caching products in the marketplace. Our architecture is different from some of those because we only require one replica copy in a proper node configuration of an odd number of nodes and things like that. We only require the one copy of the data to be done. So that's pretty much just a fixed number. You're going to have a master shard or multiple master shards, and then you're going to have a replica or multiple replicas, one for each master shard.
Great, thanks. The next question is from Brian, who asks, is there throttling between the second shard and the creation of a new third shard?
Let's see, throttling, yes. Well, I think when you're saying when the failover happens, it happens like almost instantaneously. As long as the proxy and the cluster manager are aware the first shard has a problem, the other replica is ready to go. It just needs to be promoted to the master, and the proxy knows to send the traffic to the new master, and things continue on. The creation of the third shard, I think you're asking about on node 3, was the backup to the backup. So what happens when the replica is promoted to master, you have a moment of time there where you're a little vulnerable to another shard failure. Hopefully that doesn't happen, but it could happen. So what Redis has is a optional feature to say, don't wait on an operator, don't wait on the alerts to get to somebody's pager or whatever happens. Go ahead and spin up a replica copy on yet another node that we know has capacity and that's safe, and have that ready to go in case something happens. So that's what you saw in that process. Good question, though.
Great. So we have one more question, and that's from Supriya, who asks, did you do any other tests for Redis HA? And what is your opinion on the test results?
Did I do any other tests on the Redis HA? Well, today we focused on the ones that we did. There's all sorts of tests you could do. I think the network, and I think, again, it takes a while to spin that up, so I did not choose the black hole attack. But what that attack does is go in and literally start dropping network packets and disrupting the traffic coming in and or out of the individual nodes. So that's actually a really good attack. And again, our cluster managers have become aware that the nodes are becoming, or the shards even are becoming unresponsive. And it would act in a similar fashion at some point, when it has to make the decision of keeping the high availability up, it would probably fail over to another node for the replica in that case. So yeah, Gremlin has a lot of tools that you can do a lot of damage with, but obviously we won't be able to show all those today.
Great. So that looks like all of the questions that we have for today. If you have any other questions down the line, please feel free to reach out to us, and you can join the Gremlin Slack to get your questions answered by the community. Oh, one more question, actually. Just in time, Brian. All right, so here we go. From Brian. On failure of the proxy, I assume there is a load balancing mechanism in front of it, either by the client or a load balancer in front. Yeah,
that's a great question. So by default, Redis Install is actually a DNS resolver on the hosts, and so you'll set up a static, fully qualified domain name for the cluster, And then your databases will be, the name of the database and the port they're on, .myclustername.mycompanyname.com, okay? So that gives the developers a very consistent way to come after the database, that they don't have to know where the shards live. They don't know any of that and don't care. They just access it through that URL. Now, in a situation where the proxy itself, so in the attack that brings down a whole node, if the proxy was active for that database on that node, and it can be configured lots of different ways, and it goes down, then the cluster manager is going to know that the entire node is down. There was a proxy servicing databases on that node, and it will switch over to another node in the cluster to take the work and continue on. Now, in those cases, Redis is actually super resilient during failovers of shards, and certainly with nodes as well. But if the node goes down that your proxy is on, you're literally losing your TCP endpoint. So, this is a great question. I could talk about this all day, but in the end, if you lose the TCP endpoint, you got to reconnect. That's just got to happen. So it's very important. You'll notice, Memtier will say I couldn't complete the transaction during the failover. That was an active transaction that was being processed by a shard. And we send back an error on that, a brief error, because we can't guarantee that the transaction completed. But you also notice it comes back really quick. The other connections keep going, and that connection actually probably kept going, but the individual transaction had a slight issue. So programmers definitely need to be trapping errors. We all know that, and trapping transaction failures. And in those cases, you can just retry that transaction on the same connection, and if the proxy is still there, it'll go right through. If the proxy fails, you're actually going to have a bad connection object. Let's say you're in Python or Java or whatever language you're programming in. You're going to want to take that connection object and retry the connection. And in an active-active scenario, you could build, you certainly can use Redis with load balancers and come into the proxy via that mechanism. And you can even have that automatically fail over if it detects a problem to the active copy and redirect the clients to the other cluster entirely. And that would be a great way to handle that. Or you can build it into your app that after, I don't know, I'm making up a number here, 5 times I try to connect to my cluster and I can't do it, I automatically know the backup cluster and I go ahead and try the connection there. Of course, that may be slower. It may be across a VPC peering connection. It may be, halfway around the world, but you keep going, and that's what we want to accommodate there. So that was long-winded, but I hope that answers in a lot more detail.
Awesome. And it looks like we have one more question. And folks, if you have more questions, now's the time to put those in the Q&A. So we will go to Supriya's question, which is, does open source Redis HA come with native monitoring port?
Open source Redis does not have, it has some commands that you can monitor things, but no, all of that graphing and the REST APIs that provide the metrics and the Prometheus scraping, that's part of Redis Enterprise.
Cool. Well, thanks so much, David and Tammy. We really appreciate it. And like we said, if you have more questions after this webinar, you can pop over to the Redis community forum or the Chaos Engineering Slack, and the links are there. We'll be sending out the recording to everyone shortly, so stay tuned in your inboxes. And thanks for joining us today.
Thanks, everyone.
Thank you, everyone.